mathematicians, welcome back to another video on quadratic functions. If you want to learn more about quadratic functions, link to the playlist in the description as well as up here in the info box. There's everything in there that you are ever going to need with regards to quadratic functions, so definitely check it out, it's worth it. Before we get to the so-called vertex form here on quadratic functions and also completing the square and quadratic formula, we would like to talk about what a vertex in general is today at first, because a bit of terminology is important, and once you understand what a vertex is, you can basically already read off a graph what the vertex is without calculating anything at all. So that's very important stuff, so definitely make sure to grasp the idea of a vertex today. So the vertex in general is just the highest or the lowest point of a parabola of a quadratic functions. And that's basically it. Mathematicians also call those minimum or maximum in general, or extreme points of a functions, extremal points. But we are going to go with vertex for this chapter because this is what you find in most school books. So let us sketch an example of a parabola. Really doesn't matter what it looks like, it's always the same concept. Let's say we are going to deal with a parabola that we already know about, one that is not shifted to the left or right, but neither up or down or nowhere. Let's say we have this parabola given, okay, it's a very slim one, and it passes through our coordinate systems y-axis, let's say at y being equal to 1. And since it's a stretched parabola, we can say, okay, we are going to have a function f of x being equal to, for example, 2x plus 1. Really doesn't matter, just putting in some numbers in here to make the point more clear. Now, we were dealing with those sorts of functions before, and there's a square missing. Namely, those are just functions which are shifted up or down in positive or negative y direction in our coordinate system, but neither to the left or right. So what is the vertex here? I mean, think back to what I said before. The vertex is just the highest or lowest point of a parabola. If you think about it in terms of a valley, if you search for the lowest point of a valley, it's just going to be the ground basically. If you let the ball roll down, it's going to stop at a certain point, and this is going to be the lowest point of your valley basically, which is going to be right at the intersection point basically with our y-axis. Oh, this might ring a bell for you because the intersection point with the y-axis is just given by the y-intercept. That means our vertex in some way, which consists of two variables, it's a point, it's a vertex point, it's definitely going to have as a y-coordinate just our y-intercept. I mean, this is the pure definition of the y-intercept. Namely, in our case, it's going to be positive 1. Now what about the x-coordinate of our vertex? I mean, the x-coordinate at the y-intercept, I mean, we are going to get closer and closer to the y-axis, meaning our x-coordinate is going to be 0. If we are on the y-axis, our x-coordinate is going to be 0. I mean, we have talked about this before. Meaning our vertex point lies at 0, 1 in our example. This was just a concrete example with numbers. Now what about the general situation? Basically having a function of the form f of x being equal to ax squared plus b. This could be, for example, such a function. It could be a very thick boy, and it's shifted upwards, but it's opened in the downwards y direction. Now what is the vertex here? Think back to what we just said. The vertex is the highest or lowest point on our parabola. Obviously it's the highest point. Okay, it's basically the top of the mountain, you could say. And, well, how can we find the coordinates here? I mean, once again, since we only shifted this function upwards or downwards, it's going to be definitely 0, and the point is called v. I was writing s right here because it's called Scheitelpunkt in German, starting with an s, but our vertex point v is definitely going to have 0 as our x-coordinate yet again. Now what about the y-coordinate? I mean, once again, we are just going to have the y-intercept as being the point or the spot where we are going to cut through the y-axis. Meaning our y-intercept in a general example is just going to be b. And yeah, this is basically it. For functions that are shifted upwards or downwards, but neither to the left or right, you're always going to find the vertex by just plugging 0 and b into here. And there's a special case for b being equal to 0, and those could be functions like this, for example, just a parent function, normal parabola, or it could be a function like this, and our vertex point always lies in the origin here, because setting b equal to 0 gives us a function which is neither shifted up or down, okay, but this way the vertex is going to lie in the coordinate system's origin. Now, I mean, finding out the vertex for functions of this form is very easy, but then we are going to run into problems if we take a look at the general form of a quadratic function that I have introduced in the very first episode of the series, namely f of x being of the form ax squared plus bx plus c. This could be, for example, a function looking like this. Now, algebraically, it's rather hard for students to find out what the vertex is actually going to be. If you never talked about differentiation, for example, it's going to be a handful deriving this to your students, which we are going to do in the next episodes. But if you have a graph given by your teacher, you can always find out the vertex pretty easily by just taking a look at the coordinate system's range, basically. So, for example, if this right here is x being equal to 4, and this right here x being equal to -1, then you can go here, and we know that the vertex is just the highest or lowest point of parabola, meaning our vertex in our case is going to be at 4, -1, for example. But like I just said, in a normal case, finding this out algebraically is kind of a handful and it requires a lot of work, and this is probably the most work you are ever going to do up until this point in the calculus or algebra chapters at your school. But for this, we are going to derive the so-called vertex form of a parabola, which is going to make it possible for you to find out the vertex at a glance. You can see in this form of a quadratic function, after completing the square, what the vertex is going to be. You can read off just the vertex coordinates, which I find to be very, very elegant. I always find this very cool. So yeah, I hope you are going to be prepared for that and a bit of excitement, always also playing in this whole thing for you. Other than that, thank you guys for watching. If you enjoyed this video, please like, subscribe, and comment channel. Like if you want to support channel a bit more, blah blah blah, and go to the main channel. Up until the next video, I wish you guys a flammable day. Please stay safe, okay? Don't get hit by corona. Ciao.